Okay, so here's number 3. During a demonstration, the instructor placed a 1 kilogram mass on a horizontal table that was nearly frictionless. The instructor then applied various horizontal forces to the mass and measured the rate at which the mass gained speed or was accelerated for each force applied. So they had this little thing on a table, the teacher gave it a push, and then they measured how fast it accelerated. The results of the experiment are shown below. Plot the values given in the table and draw the curve or line that best fits all points. Describe in words the relationship between force and acceleration. In other words, is it linear, quadratic, or inverse? Find the slope and estimate the y-intercept. Well, that kind of tells you that it's going to be what? What type of relationship is it going to be if I ask this in part C? Can you find the slope and y-intercept of a curve? You can find the y-intercept, but you can't find the slope. So it's going to be a line. Write the equation relating the force and find the units of the slope of the graph. Does the slope have meaning in this situation? Okay, so let's do the graph first. You'll notice that I had no numbers across the bottom, so you should have probably gone, did everybody go 5, 10, 15, 20? Yeah, I'm not surprised. And then up, what'd you go up by? You went up by 5s as well? And everyone's able to do that, right? Figure that out? Okay, so 5 and 4.9, so like really just kind of below. 10 and 9.8. 15 and 15.2, so it's above the line this time. 20 and 20.1, but it's really just like 25 and 25, 30 and 29.9. So it's just below. So now, is it a perfect straight line? It's pretty darn close, isn't it? Okay, so you literally get out your ruler. And again, do not connect the dots. Did I say that already once? Yeah. Okay, just making sure that I said it. I'm joking because I know I said it. Lots. Literally, get out a ruler. I know you can't see this. I'll get you one, Riley. You can. I have lots to borrow. Okay. Now, what you have to do is, I can do this though. Like you literally. Come on. Ruler. There it is. You literally take a ruler and you put it on there and you place it so that the slant of the ruler matches the slant of your dots as best as you can. And it's an estimation. Now there are certain, I'm going to go with like that. There are certain statistical analysis ways of figuring out the line of best fit, but for our purposes, the straight ruler, line of best fit, the eyeball method is perfectly valid. Okay? Is yours going to be exactly right? No, and I don't care. As long as your line looks kind of like this, and I can say, yeah, that's pretty good. I'm going to draw the line. As long as it looks reasonable, I'm good. Now, if you do this, come on. If you do this, and it's not even close, well, yeah, I'm going to say that's not a very good line of best fit. Okay? So as long as you get something good, get out of there. Cool. Okay. So there's our line of best fit. Describe in words the relationship. It is clearly linear, or it's a direct relationship. Find the slope and estimate the y-intercept. Okay, so to find the slope, now I've said you can pick any points you want. If that's my line of best fit, should I pick this point here or this point here? Are they the best dots to represent the slope of that line? No. You should pick dots that are on the line, or the closest ones. In my estimation, I'm going to go with those ones. Those ones appear to be the closest. Okay? Maybe this one here. Does that make sense? Okay, so I'm going to pick those ones there, and the slope is equal to, I'm going to write down here, so this one here was 9.8 minus this one here, which is 4.9, and the x's are 10 and 5. I expect everyone to be able to calculate slope now. If you're still having trouble, come and see me, we'll get it straightened out. But that's my expectation now. Whether you meet it or not is up to you. 9.8 minus 4.9? 4.9. 10 minus 5 is 5. Help me out here. 4.9 divided by 5? It's probably like 0.98. Did you get about 0.98 for your slope? You should have. What would be sort of in a range of acceptable values? Yeah, probably 0.95 to maybe 1.05. If you have 1.06, I would look at it close and say, yeah, okay, that's okay.
What was the schedule?
We haven't talked about that yet. Good question. I'll get to that. Okay. So don't worry if you don't have the exact same number as me. Okay, so find the slope and estimate the y-intercept. What would you say the y-intercept is there based on that line? It looks like to me like it's below. Do I need to zoom in a bit? Like that's about minus, if that's 5, maybe minus 0.5, roughly. Okay, so our equation is then y equals 0.98x minus 0.5. And again, I don't care how close the numbers are. Well, I mean, they got to be within reason. But as long as you can, yeah, that's about right. You know, a reasonable person would say that. That's right. Find the units of the slope, and does the slope have meaning in the situation? Let me zoom out so that we can see more. Find the units of the slope. So this y unit here is the acceleration, which is measured in meters per second squared. And this one down here is the force, which is measured in newtons. So the units are, in fact, meters per second squared per newton. Does that mean anything to anyone? Not likely at grade 11, it doesn't. It barely means something to me. Did you? That's fine. Does it have any meaning? You could say, not that I know of. Sure, why not? And I will tell you, as a little sort of bonus extension here, really, you guys know F equals ma, right? Right? Okay, so this one is really acceleration, right? And this one down here is really the force. So the slope is really a over f, right? So can I rearrange this to a over f? Well, I have to get rid of the m on this side first, right? I'm going to write it down here. This is an extension. Don't freak out if you don't know how to do this. Don't worry. This is just like really extended stuff. Okay? The slope we said was the a over the f, right? So to rearrange this for a over f, I'd have to get rid of m on both sides. And then you'd have acceleration equals f. And unfortunately, we've got m for slope and m for mass. But I need a over f, right? So it'd be 1 over m is equal to a over f. So really, the slope is the inverse of the mass. Perfectly all right if you don't get that. 15 years you go back and you go, okay, yeah, that kind of makes sense. Maybe 20? You're overestimating change. Trust me, in about 3 years you'll get it. Okay? It's not that bad. Anyways, so does slope always have meaning? It sort of does here, but certainly not a meaning that we are going to be comfortable with. So, am I going to give you that on a test?
Yes.
No. Do I look like a jerk? Don't answer that. As soon as I said it, I knew I was in trouble. Okay, are we good? Yes? What do you have to be able to do? Create a graph, find the slope, estimate the y-intercept, tell me if the slope has some sort of meaning.
So slopes like random.
What do you mean by random? Well, it's not random. You look at the graph and you say it's about minus 0.5. Are there mathematical ways to do it? Yeah. Have I tried teaching that in the past? Yeah. It's just caused too much grief. Oh, did I not do? Oh, so the equation is y equals minus 0.98x minus 0.5. It's kind of just C written all together, right? Okay. Okay. It's